Are we alone in the universe? This dizzying question is one that everyone has asked themselves. As science and technology advance, astronomers are constantly developing new and more precise ways to discover extraterrestrial life one day. In 1970, the first messages were sent into space to intelligent extraterrestrial civilizations. And even if, for the time being, we still have not received an answer, many are convinced that life is present in the universe elsewhere than on Earth. Dear traveler, good morning. Today we embark on a great journey through our solar system and beyond, into the heart of the universe, in search of clues to the existence of extraterrestrial life. But before leaving for a new adventure, think about liking the video and subscribing to the channel to not miss anything. Thank you, and have a nice trip. The testimonies of people who have encountered extraterrestrials are numerous, and many are far-fetched. But some of these stories continue to intrigue us today, because no rational explanation has yet been found. It was the case of the story which will follow. We are in China, on the evening of July 24, 1981, at 10:38 p.m. Nearly 10 million people reported having seen a light spiral in the sky for 6 to 7 minutes. This strange phenomenon was observed in several Chinese provinces: Sichuan, Yunnan, Gansu, and Qinghai. According to the testimonies, the unidentified flying object would have resembled a spiral clearly detached from the stars. And the strangest part is that this phenomenon had already been observed in the past. The hypothesis of a meteorite was quickly discarded because the data of the object did not coincide with those of a meteorite. It was moving at a speed of several kilometers per second, at an altitude of 500 kilometers, in the opposite direction of the Earth's rotation. The other theory put forward to explain this unidentified flying object is that of a spy plane. But the photos and recordings of the UFO being of very poor quality, one could never be sure of the most plausible explanation. Some scientists have tried to explain this UFO by natural phenomena in space, but no known phenomenon seems to correspond. Even if later, in 2009, hundreds of people have reported to have observed the same spiral light in the sky of Norway, before Russia explained it by a military experiment that had gone wrong. The observable universe would contain nearly 200 trillion stars. That is to say, 200,000 billion stars. How could we imagine such a quantity? There are more stars in the observable universe than grains of sand on Earth. Moreover, if we converted each star into a grain of sand, there would be enough to cover the Earth with a thickness of 10 centimeters, or more than 4 inches. There are, in the totality of the seas, oceans, rivers, and lakes of our dear planet Earth, less drops of water than stars in our observable universe. And yet, the observable universe represents only a tiny drop of water in an immense cosmic ocean. The size of the entire universe could contain a volume of space 15 million times larger than that of the observable universe. It is hard to believe that in such a large space, the universe is empty of life. And yet, even if we could say to ourselves that we are certainly not the only ones in the infinite immensity of the cosmos, At the time of today, the Earth is the only known planet where life exists. Finding traces of extraterrestrial life in the universe is one of the missions of the James Webb Telescope, which studies the atmosphere of exoplanets. Exoplanets are planets that revolve around stars other than our Sun. The first one was discovered in 1995, and since then, more than 5,000 have been discovered. The James Webb Telescope is placed in orbit around the Sun at a distance of 1.5 million kilometers from the Earth, which is about 1 million miles from Earth. But then, does the James Webb Telescope have a chance of finding life beyond our planet? The answer is yes. The American astronomer Frank Drake established in 1961 what is called the Drake equation. This equation quantifies the potential number of intelligent civilizations other than our own. According to Drake's equation, there would be a high quantifiable number of intelligent extraterrestrial civilizations, and we should find more technological than biological evidence of these civilizations. For example, long-range electromagnetic signals. Why? Simply because technological traces last longer than biosignatures, which are, for example, traces of methane or water, essential for the development of life, or organic molecules. Astronomers will therefore be able to find traces of technology left by a civilization that has already disappeared for thousands of years. In addition, scientists have determined that biosignatures would be less reliable and less easily detected than technosignatures. Have you ever heard of the Fermi paradox? This paradox hides a series of questions that Italian physicist Enrico Fermi asked himself in 1950 while debating with his friends the possibility of extraterrestrial life. Why has humanity found no evidence of extraterrestrial civilizations when the Sun is far from being the oldest star in our galaxy? Other civilizations must have lived and died out, being more technologically advanced than us. There should remain traces of these civilizations, visible from Earth like radio waves. Scientists have proven that humanity is detectable throughout our solar system. So where are the extraterrestrials or their representatives? There are several answers to this paradox. Either the probability of the appearance of a technologically advanced civilization is very low, or extraterrestrials exist, but they do not wish or cannot communicate with us. Or else, life exists elsewhere, but it is undetectable. We could imagine, for example, that it exists at the bottom of an ocean, protected by a layer of ice. The last explanation will make you dizzy. It is possible that extraterrestrials do exist and visit us, or at least send us signals, but that we are not yet technologically advanced enough to detect them. Before we leave to explore our galaxy and part of our universe in search of traces of extraterrestrial life, I'm going to tell you about some strange interstellar objects discovered by the scientific community in recent years and that have often been attributed to aliens. In 2017, Oumuamua was the first object observed in our solar system that is believed to be from elsewhere. This strange object was spotted on October 19, 2017, by the Haleakala Observatory telescope in Hawaii as it sped through the solar system. at 90,000 miles per hour, relatively close to Earth. It was named Oumuamua, which is Hawaiian for scout or messenger. Some astronomers say it is a comet. Others think it is an asteroid. But Avi Loeb, a Harvard astrophysicist, says Oumuamua is neither, but rather the first sign of intelligent extraterrestrial life. According to this astrophysicist, Oumuamua is an extraterrestrial vehicle that was propelled by a solar sail from the direction of the star Vega. Oumuamua has the shape of an elongated cigar, or a disk 10 times longer than it is wide, which resembles a spaceship, as we imagine it, rather than an asteroid. Indeed, the longest known space objects are only 3 times longer than they are wide. But that's not all. The strangest thing is that as soon as it was spotted, this curious object made a hairpin turn and accelerated towards another direction, even though it had already grazed our sun. This mysterious acceleration is difficult for astronomers to explain because it does not correspond to the behavior of a comet or an ordinary asteroid. The comet hypothesis is not convincing for many scientists because most comets have a tail. In other words, they leave a bright trail behind them as they approach the sun, heat up, and release frozen gas and dust. But Oumuamua did not have this feature, as its trajectory took it to the heart of our solar system, very close to our sun. As it got closer to the sun, it progressively accelerated to reach 87 kilometers per second, or 54 miles per second, at the closest point to the sun. It was then at 60 times the Earth-to-Moon distance. Now, if comets accelerate when they move away from the sun, it is precisely because of this tail that propels them like a rocket engine. A hypothesis has emerged from these observations. Oumuamua could be a hydrogen iceberg, that is to say, a giant piece of hydrogen completely frozen. Its tail would then not have been visible from Earth. But Loeb's team says that an object of this size could not have stayed cold enough over hundreds of millions of years, the time it would have taken to come to us from the region of space where this type of object forms. The freezing point of hydrogen is only slightly higher than the ambient temperature of the universe. Oumuamua would not have withstood the heat of stars. Loeb's theory to explain this sudden acceleration is the solar veil effect. The reflection of the light of the sun on the surface of the object would have created a thrust like the wind, pushing a boat with its sail. Loeb explains that since nature does not make sails, there is a good chance that this object is man-made and therefore extraterrestrial. In September 2020, another object received a similar push from our star, an equally mysterious 2020 SO. This is a rocket booster from the Surveyor 2 mission, launched in 1966, which had lost contact with Earth and has since drifted into space. Like Oumuamua, this object of artificial origin had a flat and reflecting surface, which could, by repelling the light, propel it forward. However, we are not yet sure that it is indeed an extraterrestrial spacecraft. Scientists have considered the hypothesis of nitrogen ice, which would have the same degree of brightness as Oumuamua, and could therefore provide the necessary thrust to explain the acceleration of the strange object. Oumuamua could therefore be a piece of nitrogen ice that was torn from a Pluto-like exoplanet about 500 million years ago. The nitrogen could have, like hydrogen, produced an invisible tail that would have propelled Oumuamua forward in a single acceleration. But the story doesn't end here. Loeb has an answer for everything. The astrophysicist denies this hypothesis by arguing that it is unlikely that the exoplanet from which the nitrogen block would come is large enough to find a fragment of this size. To use the Pluto model, its surface layer is only a few % of its size. However, even if the probability remains low, it is still possible. We do not know what distant galaxies are made of. Scientists tend to favor this hypothesis, which could, in addition, give us a glimpse of what the distant universe holds that we will never be able to observe in the lifetime of our civilization. Astronomers have also challenged the solar sail hypothesis put forward by Loeb. If it were really a solar sail designed by extraterrestrials to move through space, it would be very inefficient because it only reflects 10% of the light. To better understand the principle of the solar sail, let's make a small parenthesis. An analogy to the solar sail can be a sailboat. The light exerting a force on the mirrors is similar to a sail blown by the wind. High-energy laser beams could be used as an alternative light source to exert a much greater force than would be possible using sunlight, a concept known as a beam sail. But let's get back to our solar sail, powered solely by our sun. Light is composed of photons. Even though they have no mass at rest, they have momentum when they move, and a nice momentum, since they move at the speed of light. When they reflect on a surface, like a mirror or a piece of shiny metal, they transmit part of this momentum to this surface. This effect is negligible here on Earth, but in space, with perfectly balanced forces, this extra momentum can really add up. For example, a spacecraft flying to Mars is deviated from its path by several thousand kilometers because of the slight pressure of the sun. If mission planners do not compensate for this drift, their spacecraft will miss the planet, or worse, crash into it. Even though the total amount of pressure per square meter on a solar sail is tiny, it is constantly being emitted from the sun. And to top it off, it is totally free. And the fuel you don't have to carry with you makes your commute much lighter. Solar sails therefore offer the possibility of low-cost space flights combined with long lifetimes. As they have few moving parts and do not use a thruster, they can potentially be used many times for payload delivery, for example. To give you an idea, let's take the total force exerted on a solar sail of 800 by 800 meters, or 2,600 by 2,600 feet. This force is about 5 newtons at the distance of the Earth from the Sun. This makes it a low-thrust propulsion system because the amount of acceleration is very small, but it is a constant pressure from the Sun, and it can build up over a long period of time. Our 800 by 800 meter, or 2,600 by 2,600 feet, solar sail could receive an acceleration of 1 millimeter per second, but exponentially. So in the first second, the sail travels 1 millimeter, then 2 millimeters in the next second, and so on. You guessed it. The bigger the canopy, the higher the acceleration speed. Thus, in the course of a year, this spacecraft could go at 30 kilometers per second, or 18 miles per second. Just for comparison, NASA's Voyager 1 probe only goes at about 17 kilometers per second, or 10 miles per second. Thus, without a starting speed with a 2-ton load, such a spacecraft would take 400 days to reach Mars, 2 years to get to Jupiter, a little more than 3 years to arrive in the Saturn system, 6 years to approach Uranus, and finally, 9 years to arrive at Neptune. With conventional propulsion systems and a precise launch window to obtain the gravitational impulse of Jupiter or Saturn, a similar mission would take about 13 years to reach Neptune. But these advantages also have their drawbacks. Solar sails depend on the properties of their host stars. Solar sails are ineffective when dealing with M-type stars, i.e. red dwarfs, because the radiation pressure is not high enough to generate enough velocity to escape the star system. This is a problem, since ultra-cool, low-mass M-type dwarfs represent the vast majority of stars in the universe, accounting for 75% of the stars in the Milky Way, for example. Red dwarfs are also incredibly long-lived compared to other classes of stars, and can remain on their main sequence for up to 10,000 billion years. Therefore, a propulsion system that can accommodate red dwarfs would be preferable. An alternative to the solar sail would be the electric sail. So instead of a conventional sail, here, the electric sail would generate a magnetic field via a sail of small wires, which would repel the solar wind. The difference? Electric sails rely on the impulse transfer of charged particles from the solar stellar wind, protons in our example, by deflecting them via electric fields, while solar sails rely on the impulse transfer of photons emitted by the star. Thus, the wind of the star drives electric sails, while the electromagnetic radiation emitted by the star drives solar sails. A spacecraft combined with an electric sail represents a better means of propulsion near most types of stars, not just for gram-scale spacecraft. But it would take a lot longer for an electric sail spacecraft to reach speeds that would make interstellar travel practical. If we consider solar sails powered by laser arrays, then it is possible to directly reach speeds of 10% of the speed of light via light sails, where in contrast, electric sails powered by stellar winds reach speeds of only 0.1% of the speed of light. While an electric sail could eventually reach 10% of the speed of light by repeatedly approaching different stars, it would take more than 10,000 stellar encounters to reach such a speed, which would take at least 1 million years. While 1 million years is only a blink of an eye in cosmic terms, on the scale of a civilization like ours, it is a very long time. As a species, humanity has only existed for about 200,000 years, and has only recorded its history for about 6,000 years. But we have only been a spacefaring civilization for 60 years. However, a sail capable of being accelerated by lasers remains the most practical way to explore the first exoplanets in our lifetime. Extraterrestrials technologically advanced enough would still have made a more efficient choice of propulsion. Whatever the explanation of this strange interstellar object, astronomers have not yet agreed on the most plausible hypothesis. And what further complicates the conclusions is that most of Oumuamua's strange characteristics have been inferred via models since we have not been able to observe this object in detail. On August 30th, 2019, an engineer and amateur astronomer named Gennady Borisov observed from his personal observatory in the Crimea an object moving across the sky in a different direction than comets in the asteroid belt of our solar system. An unusual observation. The object was identified as a solitary comet, meaning that it moves in space without being bound to a star. This was the first interstellar comet ever discovered, so you can imagine hypotheses related to extraterrestrials were flying to explain this new phenomenon. But it was quickly established that 21 Borisov is in fact a rather common comet, although a lonely one. It would be composed of a muddy mixture of water, dust, and carbon monoxide, and it has a visible tail, unlike Oumuamua. One hypothesis is that this comet was torn from an ancient solar system centered on a red dwarf, which could be the star Ross 573, which is now a white dwarf. This star is located at 65 light-years from the Sun. The comet 21 Borisov would have been propelled to our solar system after a violent collision 900,000 years ago. But astronomers are not totally convinced by this hypothesis, and the mystery remains. It has been traveling for far too long to be linked to a specific star system. In any case, no one in the scientific community anymore thinks that this comet is an extraterrestrial object, unlike Oumuamua. On January 8, 2014 at 5 p.m., a mysterious object from outer space fell into the Pacific, but the scientific community still lacks data to be able to find an explanation. The object, which has been named CNEOS-2014-01-08, crashed in the middle of the Pacific Ocean, 200 kilometers or 125 miles off the coast of Papua New Guinea. Surprisingly, it is only 45 centimeters wide, or less than 18 inches. It would have arrived on Earth at a very high speed of 216,000 kilometers per hour, or 135,000 miles per second, by following a hyperbolic trajectory, which proves that it is of interstellar origin. This would be, if you have followed correctly, the first object of interstellar origin to have been spotted from Earth before Oumuamua or Comet 21 Borisov. You are probably wondering why no one has asked where this object came from and if it was an extraterrestrial object, while Oumuamua has been the subject of numerous searches since 2017. Simply because the data identifying this object come from spy satellites of the American Department of Defense, the U.S. Space Command. It is therefore secret data that have only recently been declassified. The zone in which this strange object crashed is used by the American Army to monitor possible nuclear explosions. It could be a meteorite, which would not be so surprising because they are rather frequent on Earth. But what makes it more unusual than the others is that it comes from another solar system than ours. When it crashed into the ocean, this meteorite had an estimated heliocentric speed of about 60 kilometers per second, or 37 miles per second, which is rather high and excludes the hypothesis that it was deviated by gravitation in our solar system. For the moment, some have launched research to find these pieces of meteorite in the Pacific Ocean. The objective is to analyze the composition of the object to verify if it is natural or artificial. Fasten your seatbelt. We are now going to explore our solar system in search of traces of extraterrestrial life that would have existed several million years ago, or even that would still exist. We begin this exploration of our solar system with Venus. After Mercury, it is the second closest planet in our solar system to the Sun. But unlike Mercury, Venus is hotter, which is why it is often described as hell. Temperatures can reach 500 degrees Celsius, or more than 930 degrees Fahrenheit. It is therefore impossible to find on Venus liquid water, nor organic molecules that would be destroyed by the heat. Moreover, Venus is surrounded by pale yellow clouds, composed mainly of tiny droplets of sulfuric acid, which, like terrestrial rains, fall on the surface of the planet. Problem: sulfuric acid is destructive to all forms of life. On top of that, the pressure on the surface of the planet is 92 times higher than on the surface of the Earth, and the atmosphere of Venus is composed of 96% carbon dioxide. You're going to tell me that we should turn back. We will never find traces of life on such a planet, but astronomers are not so categorical. A team of Anglo-American scientists has identified, by scanning the sky of Venus with 2 radio telescopes, the presence of a gas in its thick mantle of clouds, the phosphine. This gas is a chemical compound found on Earth. It is a deadly gas. It is used to prepare poisons in the field of weapons or pesticides. But it is also, paradoxically, a reliable indication of the existence of life forms. This study is still very recent, since its conclusions were published in 2020 in the journal Nature Astronomy. NASA considered this announcement important, but astronomers remain cautious and ask for new observations, including sending a probe to Venus. This would be a first, since until now, our search for extraterrestrial life has always focused on Mars. The upper atmosphere of Venus offers milder temperatures, low enough for water droplets to form. Potentially, life could develop there, unlike on the surface of the planet. The pressure and temperature conditions of the troposphere, at about 55 kilometers from the surface of Venus, are similar to those found on Earth. However, the composition of the air remains different because it is mainly composed of carbon dioxide. There cannot be life forms similar to ours in the atmosphere of Venus, but it is quite likely that other life forms have developed there. Moreover, studies have found the presence of carbonyl sulfide in the atmosphere of Venus, a gas that is very difficult to produce inorganically. This could be an indirect proof of the existence of living microorganisms in the atmosphere of the planet. But the life in the atmosphere of Venus can also come from the Earth. Yes, the planets of our solar system could have exchanged materials in the past. Imagine that a meteorite hit the Earth, throwing materials from the Earth into space, and that these rocks then collided with Venus by crossing its orbit. The rocks of the Earth could have contained microbial life, which, like the acid-resistant bacteria on Earth, developed and adapted to the conditions of the Venus atmosphere. It is also likely that before Venus became a hell, it too, like the Earth, sheltered life. It is often said that Venus and Earth are twin sisters. They have the same age, about 4.5 billion years, and they are similar in size and mass. Models show that the surface of early Venus was very similar to those of early Earth, with lakes, oceans, and mild conditions. Life could have formed on the surface of the planet several billion years ago, before Venus became a hell. Astronomers believe that the environment of Venus was perfectly habitable for 2 to 3 billion years after its formation, during which time temperatures could have been stable between 20 degrees Celsius and 50 degrees Celsius, i.e. about 86 degrees Fahrenheit. Life would have had plenty of time to emerge. 3 billion years is enough time for an intelligent civilization to emerge, as we can see with the example of the Earth. The oldest traces of life on Earth date back only 3.8 billion years. But then, how did Venus, from a habitable planet similar to Earth, become such a hell? It is estimated that 4.2 billion years ago, shortly after the formation of the planet experienced a period of rapid cooling, during which silicate rocks absorbed carbon dioxide from the atmosphere and locked it in the crust of the planet. 715 million years ago, the atmosphere of Venus was still similar to ours, with a dominance of nitrogen and traces of carbon dioxide and methane. These conditions would have remained stable if there had not been massive volcanic outgassing. An episode of intense volcanic activity would have caused the release of a large amount of carbon dioxide trapped in the rocks of the planet into the atmosphere of Venus, causing a mass extinction, if, however, there was life on Venus at that time. All this is only a hypothesis based on what we know. Because the Earth has experienced a similar event 252 million years ago, this episode, called the Permian Crisis, marked the largest mass extinction on Earth since its formation, wiping out 95% of marine species and 70% of terrestrial species. This unprecedented extinction is believed to have been caused by intense volcanic activity in the Siberian traps, resulting in a massive release of CO2. The release of this gas in large quantities into the atmosphere would have led not only to a massive warming, but also to a very strong decrease of the oxygen level in the oceans. We are leaving Venus for Mars, the red planet. The search for extraterrestrial life in our solar system has so far focused mainly on Mars, because this planet next to ours has some similarities with Earth. First, a day on Mars lasts the equivalent of 24 hours and 37 minutes on Earth. In addition, the axis of rotation has a similar inclination, so the rhythm of the seasons is close, even if the Martian year is about 2 Earth years long. Since the middle of the 19th century, we have been interested in the possibility of the existence of life on Mars, especially since the observations showed dark areas, which could correspond to oceans, and lighter areas, which could be continents. In 1884, spectrological analyses of Mars showed that the red planet contains neither oxygen nor water. In 1965, the American probe Mariner 4 was the first to fly over and photograph Mars. These images showed that Mars is covered with craters and that there are no lakes or oceans. Other measurements showed that water cannot exist in liquid form on Mars, notably because of the presence of about 6 HPA compared to 1013 HPA on Earth. Finally, the Mariner 4 probe also denied the existence of life on this planet because it is not protected by a magnetosphere like the Earth. It is therefore reached by cosmic rays from the universe, hostile to life. After these discoveries, astronomers have been looking for the existence of living microorganisms in the soil of Mars without ever being able to prove it in an irrefutable way. The experiments of the Viking probe in the 1970s were not conclusive. More recent explorations aim at answering a question we all ask ourselves. is there water in liquid form on Mars? Or rather, have there been in the past lakes and oceans on Mars as on Earth? Scientists have found a mineral on Mars that only forms in the presence of water, hematite. But this does not prove that the planet has indeed hosted liquid water in the past. In June 2000, gullies of liquid water were discovered at great depths near the core of the planet. But these gullies may be due to other phenomena. The same type of flow was discovered on the Moon in 2006, which has never had liquid water on its surface. Fortunately, this trial and error paid off. On August 12, 2005, the MRO spacecraft was launched into orbit around Mars as part of NASA's Mars Reconnaissance Orbiter mission. This mission, in addition to the explorations of the Curiosity, Perseverance, and Zhurong rovers, which survey the red planet and analyze its soil, have made some interesting discoveries. There are indeed traces of ancient lakes and rivers on Mars, marked by the presence of sedimentary deposits, such as clays and sandstone. Clays, which are also found in the Earth's crust, are irrefutable proof of the presence of water in the past on Mars, because they are deposited in aqueous environments that remain stable for long periods. These findings have allowed scientists to estimate that there was liquid water on Mars 3.8 billion years ago, and up to about 2.5 billion years ago. Other studies suggest that liquid water flowed in the Ladon Basin for about 1.3 billion years, a period long enough to support the development of life. Recent data from the Chinese rover Zhurong even suggested that in some regions of Mars, water was still flowing on the planet only 700 million years ago. Even better, recent observations published in the journal Nature Geoscience have revealed water flows along craters on the surface of Mars itself, near the equator. This water would appear seasonally. It appears as dark lines that appear and disappear in the warm seasons, called recurrent slope lines. We do not know for the moment where this water comes from, nor what its composition is. It could come from the melting of ice in the basement of Mars, from an aquifer, or from the atmosphere of the red planet. We don't currently know if there is life on Mars, but in view of the recent discoveries, hopes remain high. After all, it is not as cold as we thought for a long time. The temperature at the equator of Mars can reach an average of 20 degrees Celsius, or about 68 degrees Fahrenheit. We continue our journey into the heart of our solar system towards Jupiter, the planet that lies just after Mars. Jupiter is the largest planet in the solar system, and the second largest celestial body after the Sun. One of the particularities of this planet is the moons that orbit it. Astronomers have counted no less than 79 of them, and still, it is possible that others will be discovered in the future. 12 moons have been discovered only recently, because Jupiter is so bright that it obscures the smaller moons. The 4 main moons of Jupiter, called the Galilean moons, are named Ganymede, Europa, Callisto, and Io. For the record, these are the names of the lovers of the Greek god Zeus, corresponding to Jupiter in Roman mythology. The moon Europa is the one that intrigues scientists the most. With its diameter of 3,122 kilometers, almost 2,000 miles, it is the smallest Galilean satellite, and it is covered with glowing ice on 100-kilometer thickness, that is to say, approximately 60 miles thick. Its orbital radius is 671,100 kilometers, or 415,000 miles, and it completes a full orbit around Jupiter in 3.5 days. Yet it is a serious candidate in the search for life in our galaxy. Scientists believe that it harbors a vast internal saltwater ocean that contains 2 to 3 times more water than the Earth, and that aquatic life is possible there, thanks to the heat of the nickel-iron core. This assumption was confirmed by NASA in 2016, despite the lack of scientific evidence. In addition, its atmosphere is composed of oxygen. The latter does not have a biological origin because it comes from water vapor generated by the interaction between light and the icy surface. The moon Europa would have, according to scientists, characteristics similar to Greenland. The layer of ice on the surface would be a real dynamic system, which allows the exchange of nutrients with the outside, and thus the development of life. Scientists have been able to draw a parallel between the double ridges that are found all over the surface of Europa and the one that was discovered in northwestern Greenland. The moon Europa is outside the zone of habitability, defined by astronomers in our solar system, but it still has a high probability of harboring life. NASA and ESA have already developed plans for space missions that will aim to verify or not the presence of water pockets under the double ridges, as in Greenland. We continue our journey to the next planet away from the Sun, Saturn. After Jupiter, it is the second largest planet in the solar system. You can recognize it by its impressive thick rings. According to astronomers, these ice rings were formed after one of its first moons collided with the planet. It is estimated that Saturn has nearly 200 moons, although 83 have actually been observed. As you can see, their sizes vary greatly. Some moons are less than 1 kilometer or 1 mile in diameter, while Titan, Saturn's largest moon, is 6% larger than the planet Mercury, at 5,150 kilometers or 3,200 miles in diameter. Also known as Saturn VI, Titan alone accounts for 96% of all matter orbiting Saturn. It is the second largest satellite in our solar system, after Ganymede, which is the largest satellite of Jupiter. Titan was the first moon observed around Saturn in 1655. It is the only satellite to have a dense and thick atmosphere, composed of 98.4% of nitrogen and 1.6% of methane and ethane, which has caused many problems for scientists to observe the surface of this moon. It is composed mainly of rock and frozen water, but lakes of liquid hydrocarbons were also discovered in 2004 in its polar regions. There are even dunes and coasts, like on Earth, which could have been formed thanks to Titan's climate, with wind and methane rain. Because there are liquids on the surface and under the surface, and a thick atmosphere composed of nitrogen, scientists believe that Titan is very similar to the early Earth, but colder. Thus, Titan could harbor microbial life, either on the surface of the planet or under the surface in an internal ocean, like Jupiter's moon Europa. This life could take the form of microbes and extremophiles in the inner ocean, or could take the even more extreme form of methanogenic life forms. As has been suggested, life could exist in Titan's liquid methane lakes, just as organisms on Earth live in water. Such organisms would inhale dihydrogen, H2, instead of oxygen gas, O2, metabolize it with acetylene instead of glucose, then exhale methane instead of carbon dioxide. Another moon of Saturn has aroused the curiosity of astronomers in search of extraterrestrial life in our solar system: Enceladus. This moon was discovered in 1789 and is the sixth satellite of Saturn in terms of size. The Cassini probe, which arrived in Saturn's orbit in 2004, detected surprising characteristics of this moon that could mean it harbors life. Enceladus is covered with ice like Europa. Like Jupiter's moon, it has an internal ocean of liquid water. Scientists discovered this feature of the Saturnian moon through the observation of strange geysers. Analyses revealed that they are highly concentrated in dihydrogen, H2, and carbon dioxide, CO2, but also in methane, CH4, in large quantities. Scientists, even with models, have difficulty explaining why so much methane is found in the geysers of Enceladus. An abiotic production of methane, that is to say, without intervention of the living, would not reach such concentrations. Unless it occurs, as on Earth, a phenomenon of methanogenesis, where microbes use dihydrogen as an energy source to produce methane from CO2. Does this mean that there are indeed living microbial organisms on Enceladus? Or is methane produced by chemical processes that are not yet known? For the moment, scientists do not have answers to these questions, but missions are being prepared to find out for sure, especially since it will be necessary to wait until 2050 to know more favorable conditions at the south pole of the moon, which is subject to eruptions. Uranus, the seventh planet of the solar system, has not interested the scientists until now. If it was visited by the Voyager 2 probe in 1986, very few missions have been carried out since by NASA to understand this ice giant. And yet, NASA plans to launch a probe to Uranus as early as 2031. There is indeed a lot to understand. Uranus is composed mainly of water, ammonia, and methane in solid form. It is well surrounded, since 13 rings and 27 moons orbit around it. Its magnetic field is strange because it is off-center. It is offset from the polar axis and inclined at 59 degrees to the planet's rotation axis. Uranus is thus lying on its orbit. Its poles are where the Earth has its equator. Another characteristic of Uranus is its freezing temperatures. Uranus is not the farthest planet from the Sun in our solar system. This title belongs to Neptune, but it is indeed the coldest. Its temperatures go down to minus 224 degrees Celsius, or minus 371 degrees Fahrenheit. If Uranus is so cold, it is because it does not create any internal heat. Its core temperature is 4,727 degrees Celsius, or 8,500 degrees Fahrenheit, which is only 1/5 of the temperature of Jupiter's core. Other strange phenomena have been observed on Uranus: radiant auroras, bright clouds, violent winds, the most powerful in the solar system after those of Neptune. Even if Uranus intrigues the scientists, it is very unlikely to find an extraterrestrial life form there. On the other hand, its moons, such as Europa or Enceladus, could perhaps shelter internal oceans. Let's continue our journey towards Neptune, the eighth planet of the solar system. It is also the densest planet. It was discovered at the beginning of the 19th century by deduction before being observed by the French astronomer Alexis Bouvier, who had noticed unexplained gravitational perturbations on the orbit of Uranus. Neptune is, like Uranus, an ice giant. Its atmosphere is composed mainly of hydrogen and helium, with traces of hydrocarbons and volatile substances like water, ammonia, and methane. Its interior is composed of ice and rocks. As you can see, the planet Neptune is blue. It is the methane that absorbs light in the reddish wavelengths and makes Neptune appear blue. But this blue color, so characteristic of Neptune, is close to the blue-violet. Methane cannot be the only responsible for this hue. With methane alone, Neptune would be blue-green like Uranus. Therefore, other chemical elements still unknown are responsible for this characteristic color. The main characteristic of this planet is that it is very active from a meteorological point of view. We can observe the strongest winds of the solar system, which can reach a speed of 2,100 kilometers per hour, or 1,300 miles per hour. But it is uninhabitable, according to astronomers, since its temperatures can go down to minus 218 degrees Celsius, that is minus 360 degrees Fahrenheit. Astronomers are interested in Triton, the largest of Neptune's 14 moons. A mission should be launched in 2026 to detect if Triton hides an internal ocean, like the moons of Jupiter and Saturn. Theoretically, it would be possible that liquid water is present between 20 and 140 kilometers deep, that is, around 30 miles deep. If inner oceans are indeed found on Triton, it would be an interesting discovery for scientists, who, in addition to looking for aquatic life, could use the fumaroles observed on this moon to explain the formation of inner oceans in our solar system. We are now leaving our solar system in search of planets that could host life. For decades, the search for extraterrestrial life was limited to our solar system. But in the 1990s, astronomers discovered exoplanets, planets that orbit stars other than the Sun. It is estimated that the number of exoplanets in our galaxy alone is at least 100 billion. The number of galaxies in the observable universe is estimated at 2,000 billion. Beyond this frontier, the universe is still expanding. This means that even if planets were home to extraterrestrials, our current telescopes like Hubble and James Webb would not allow us to see them directly. To find among these exoplanets candidates for the development of life, astronomers will therefore look for clues rather than direct evidence. To find a planet that could potentially harbor life, they rely on what is known. They are looking for a rocky, not gaseous planet with liquid water on its surface. Why liquid water necessarily and not frozen, for example? Liquid water allows molecules to meet more easily and to interact, which is essential for the development of life as we know it. This is exactly what we are doing on Mars. Scientists are looking for liquid water to be able to affirm that life is possible there. For the planet to have water in liquid form, it must meet two criteria. Its mass must be close to that of the Earth. If it is too massive, its gravity will attract all the surrounding gases. We will have a gaseous planet and not a rocky one, like the biggest planets of our solar system: Jupiter, Saturn, Uranus, and Neptune. But conversely, if it is not massive enough, it will have a gravity too weak to retain its atmosphere, which will then be lost in space. Without an atmosphere, the water on the surface evaporates instantly. There is a second criterion that must be met for the planet to have water in liquid form. The surface temperature must be moderate. Neither too hot, because this would cause the water to evaporate, nor too cold, because the water would freeze, as on Neptune or Uranus. Astronomers have thus defined what is called the habitable zone. It corresponds to the area around the star where water in liquid form is possible. Astronomers are now asking themselves a crucial question: where to look for such a planet in the immensity of the cosmos? Around what type of star? it is a bit like looking for a needle in a haystack. And above all, if there is a planet that meets all the conditions very far from us, how to detect it? To detect an exoplanet, two methods exist. One can measure the luminosity coming from a star. When the exoplanet passes in front of its star, we observe a mini eclipse with a decrease in the luminosity of the star. This mini eclipse betrays the presence of the exoplanet, even if we do not see it. We can also be interested in the movement of the star rather than its luminosity. When a planet orbits around it, its gravity will produce an oscillation effect. These methods have their limits. If the star is very large compared to the exoplanet, we may not be able to detect variations in luminosity or motion. They would work very well for a configuration similar to the Earth and the Sun, since the Sun is 330,000 times the mass of the Earth. I remind you that the Sun is not really considered as a big star. Astronomers, therefore, prefer to look for exoplanets around orange and red dwarfs, which are smaller, especially since they are more numerous. If we take the Milky Way as an example, red dwarfs represent 73% of the stars and orange dwarfs 13%, against only 6% of yellow dwarfs like the Sun. Problem: orange and red dwarfs emit much more X-rays, which are dangerous for life. Orange dwarfs emit 5 to 25 times more radiation than our Sun, and red dwarfs 80 to 1,600 times more. Now you understand better why astronomers have not yet found extraterrestrial life in the universe. The ideal would obviously be to be able to find a planet like the Earth, which orbits a star the size of our Sun. Perhaps the new generations of telescopes will allow us to solve this puzzle? Let's say we find a planet that has all the ideal conditions to support life. It is a rocky planet that orbits in the habitable zone of its star, similar to our Sun, and has a mass close to that of the Earth. Liquid water probably exists on its surface. But how do we know if life is present? For lack of being able to directly observe extraterrestrials, scientists are looking for clues indicating the possible presence of a form of life. This is what is called biosignatures. Thanks to spectroscopy, we can look for biosignatures in the atmosphere of exoplanets, even if they are too far away to be observed accurately. When you pass sunlight through a prism, you can see the white light spectrum, as well as some kind of black lines called absorption lines. These holes are caused by the gases that the light has passed through before reaching us. As each gas has its own absorption lines, we can deduce by observing the spectrum which gases have passed through the ray of light before reaching us, and therefore the gases that are contained in the atmosphere of the planet observed. We can even, thanks to complicated calculations, estimate the proportions of these gases. With this method, scientists will look for oxygen, which represents, I remind you, 20% of the Earth's atmosphere. Oxygen is released by plants, algae, and bacteria through the process of photosynthesis. As is often the case, this method has its limits. Large quantities of oxygen could come from a phenomenon unrelated to life, which we simply cannot imagine or explain with our current knowledge. The reverse is also true. It may be that life forms exist, but they are not similar to what we know, and that oxygen is not relevant to discover them. Scientists will therefore not only look for biological traces, but also for technological traces, which could be more numerous than biosignatures. We are back to the Drake equation. Remember that equation, that we should find more technological evidence than biological evidence of extraterrestrial civilizations, that can only exist in the infinite vastness of the universe. We are now about 475 light-years from Earth, in the constellation Lyra. The planet you are looking at is Kepler 438b. This planet has long fascinated astronomers because it is the closest exoplanet to Earth ever discovered to date. On the TSI, i.e. the Earth Similarity Index used by astronomers, Kepler 438b has a score of 0.88, which is a good score, since the closer the index is to 1, the more similar the planet is to Earth, and the closer it is to 0, the further away the planet is. However, it is far from sufficient to determine whether or not an exoplanet is a good candidate to replace the Earth. Let's take the example of Mars. The red planet seems today to be the most favorable for the development of life among all those which make up the solar system. Its similarity index with the Earth is 0.815. This is less than that of Venus, whose index is evaluated at 0.979. Yes, Venus is more similar to Earth than Mars according to this tool. However, its thick atmosphere is very rich in greenhouse gases. Thus, the average temperature at the surface of the Shepherd star is 460 degrees Celsius, or 860 degrees Fahrenheit. In view of these data, our twin appears much more hostile. This is why researchers cannot rely solely on the TSI to select potentially habitable planets. But then, what about Kepler 438b? Kepler 438b apparently meets all the conditions required for the development of extraterrestrial life. It is located in the habitable zone of its star, neither too close nor too far away, so it could contain water in liquid form. As for the question of mass, it is 12 times larger than the Earth. It is more likely to be telluric, and not, like Saturn and Jupiter, gaseous. Unfortunately, such a perfect planet would have been too good to be true. Recent studies have raised a few characteristics of Kepler 438b that could well be obstacles to life. For starters, this exoplanet orbits its sun in only 35 days, which is very fast. And above all, its star is a red dwarf, and not like our sun, a yellow dwarf. Kepler 438b therefore receives 40% more radiation than the Earth. There is one more thing. Kepler 438b's star is capable of powerful coronal mass ejections, which are bubbles of plasma that form on the surface of a star and can create magnetic storms when they come into contact with a magnetic field. To give you an idea of the power of this phenomenon, you should know that a coronal mass ejection releases as much energy as 100 billion megatons of TNT. If Kepler 438b has no atmosphere, then it would be particularly vulnerable to these coronal mass ejections, which would make it a hostile environment for the development of extraterrestrial life. And such ejections would occur every few hundred days. Thus, Kepler 438b could be an arid world empty of any life form. GLIESE 581c is another exoplanet that could well host extraterrestrial life. Located at about 20 light-years from Earth, it meets the necessary conditions. It is a telluric planet, which is in the habitable zone of its star, GLIESE 581. Moreover, its star is much more stable than the red dwarf around which Kepler 438b orbits. Astronomers have indeed observed that the variations of luminosity of the star of GLIESE 581c remain minimal, and would therefore not produce too extreme temperature changes. The conditions for the appearance of life are thus met, but also the conditions necessary for its extinction. But astronomers have learned not to rejoice too quickly. The star of GLIESE 581c remains a red dwarf, and violent eruptions would not be impossible. Moreover, it is not because GLIESE 581c has characteristics close to the Earth that it resembles it in every way. Look at Venus, which was the twin sister of the Earth a few billion years ago, and which is its opposite now. But following the different analyses, GLIESE 581c could be an ocean planet. Astronomers remain cautious because they have observed that GLIESE 581c is in synchronous rotation with its star, which would mean that it always presents the same face to its central star. This means that one side, the one exposed to the sun, would be too hot for the development of life, and that the other side would be too cold. Could life develop at the terminator, the line that separates the lit and unlit sides of the planet? Is such a thing simply possible? In any case, extraterrestrial life on GLIESE 581c would be quite different from life on Earth. It would be confined to a small band only, and as the star of GLIESE 581c is a red dwarf, the sky would be red and the plants black to absorb a maximum of energy. So is GLIESE 581c home to extraterrestrial life or not? To find out, astronomers sent a radio signal to GLIESE 581c on October 9, 2008. It will reach it in 20 years in the spring of 2029. And if the extraterrestrials answer us with a similar means of communication, we will receive the answer only in the fall of 2049. With the immensity of the universe, we must be patient. Now that you have seen the planets that astronomers believe are most likely to harbor life, let's go in search of the mysterious traces of extraterrestrial life that have been found in the universe. Let's go back to Fermi's paradox. There should be several thousand extraterrestrial civilizations, but we have not seen any sign of them yet. The universe is and remains silent. How is this possible? Maybe we have seen signs, but we have interpreted them as phenomena in accordance with our models. Or maybe we don't yet have the technological capacity to detect the signs sent by extraterrestrials. I'm going to show you 2 places in the universe that could, according to some, be explained by the presence of extraterrestrials. We continue our journey to the constellation of Cygnus, about 1,470 light-years from Earth, in the direction of Tabby star, or KIC 8462852. This yellow-white star is not very original. Its mass is 1.4 times that of the Sun, and it is not even visible to the naked eye, unlike, for example, Sirius or Rho de Cassiopeia, and yet it intrigues astronomers because of its strange behavior. Tabby's star shows very unusual variations in brightness. For more than 100 years, scientists have observed decreases in brightness of up to 22%, sometimes over several days, aperiodically. There could be several explanations. Explanation 1. A celestial body passes in front of the star in an irregular way, but 2 reasons contradict this hypothesis. First, no star or planet has been observed passing in front of Tabby's star. Furthermore, if a planet the size of Jupiter were to pass in front of the star, it would only cause a 1% variation in brightness and would be regular. Explanation 2. The star is surrounded by a ring of dust or fragments of large comets. This hypothesis has also been verified and rejected by scientists. Explanation 3. The variations of luminosity are caused by disturbances on the surface of the star. Here again, the observations of astronomers have invalidated this hypothesis. Explanation 4. The luminosity variations can be explained by a technical problem of the observation satellite, but no problem was found. Explanation 5. Tabby's star would belong to a class of stars whose luminosity fluctuates. But in reality, Tabby's star belongs to the main sequence, the area where most observable stars are found, and it is of spectral class F3, which means that it is just a little bit bigger and hotter than our Sun. Theoretically, its luminosity should therefore be stable and not change for several billion years. Explanation 6. These are artificial variations of luminosity. These variations could then be caused by the activities of an extraterrestrial civilization, very advanced in technology, which could have built a Dyson sphere around its star. The Dyson sphere, or artificial biosphere, is a hypothetical megastructure that was described in 1960 by the mathematician and physicist Freeman Dyson. The Dyson sphere would be a sphere of artificial and hollow matter located around a star. The objective of such a structure would be to capture the light energy emitted by the star, all or only a part, to use it in an industrial way. This hypothesis, which would mean that there is indeed an exoplanet in the vicinity of Tabby's star that harbors a highly advanced extraterrestrial civilization, has not yet been disproved. The SETI Institute has monitored radio and laser emissions from Tabby's star and has not detected any emissions. But this does not mean that there are no extraterrestrials in this part of the universe. Only very powerful emissions directed towards us could have been detected. One could also imagine that aliens mask their radio or laser emissions so that they cannot be detected. Explanation 7. The last explanation, and the one that astronomers favor for the moment, is the passage of huge clouds of interstellar dust in front of Tabby's star, which would lower certain colors of the light spectrum. Let's leave behind this mysterious enigma and go to another place of the universe much darker. The Bouvier Void, also called the Great Void or Supervoid, is another mysterious object in the universe that intrigues scientists. This region of intergalactic space contains very few galaxies, while measuring about 330 million light-years in diameter. This void was discovered by Robert Kirshner and his team in 1981. In 1997, it was estimated that there are about 60 galaxies in the Bouvier Void. To give you a better idea of the magnitude of this supervoid, if our galaxy, the Milky Way, was at the center of the void, we would not have known that there were other galaxies until the 1960s. The theory favored by scientists to explain this void is that it was formed from other voids of smaller dimensions, in the same way that soap bubbles come together to form a single soap bubble of larger size. This is the phenomenon of coalescence. Another theory had been put forward, according to which the vacuum was simply an area of the universe that had been cleaned by gravitational forces. But not enough billions of years have passed for this to have happened. But other astronomers are not convinced by this explanation. After all, these large voids are not very common in space, so why wouldn't the explanation be artificial? When you look at the night sky, you can see that the universe is composed of billions of stars, grouped in galaxies, which form clusters of galaxies. Each galaxy cluster is relatively close to its neighbor. The vacuum therefore exists in space, but not on such large areas. A theory has emerged involving the presence of extraterrestrials. The supervoid would have been formed by the expansion of a Type 3 civilization on the Kardashev scale. Such a civilization would be able to collect and consume all the power emitted by its galaxy. It would have been able to build a gigantic Dyson sphere, which would have occulted all the stars and galaxies present in the void. This hypothesis could explain the spherical shape of the void of the Cattleman. You wonder if extraterrestrial life would have had time to develop so much technologically? The answer is yes. The Bouvier void is located 700 million light-years from Earth. What we observe is what it was 700 million years ago. Astronomers estimate that intelligent life could have appeared in the universe 4 billion years ago. A civilization that appeared 4 billion years ago would have had 3.3 billion years to develop and build such a structure. But for the moment, no evidence has been found to confirm such a hypothesis. Our journey is coming to an end. During this journey, you will have discovered strange objects that suggest that life is not limited to our little planet. These discoveries are very exciting for the scientific community, but don't forget that on the scale of the universe, a civilization lasts the time of a blink of an eye. Even if we are lucky enough to spot an extraterrestrial civilization one day, it will certainly have existed and disappeared several million years ago. To be able to touch life at our fingertips, it would not only have to be spatially close to us, but also to have occurred at the same time as our civilization. The probability of communicating one day with extraterrestrials is therefore extremely low. But this does not mean that scientists are abandoning their quest. Observing other civilizations, even if they have disappeared for millions of years, will remain very interesting, and above all, very instructive.